Nowadays, microscopes are widely used for research as well as academic experiments in school and colleges, while simple microscope and compound microscope are used commonly for studies, but stereo microscope is no less. Stereo microscope, also known as dissecting microscope, is an optical instrument used for the observation of objects in low magnification, in which the instrument uses the light reflected from the surface rather than using the transmitted light from the object. It helps in examining the object in 3D. Also, it uses two separate optical paths so that the object is viewed from a different angles. Part of the stereo microscope. Stand and arm connects between the base and the head part as the backbone. Base act as the foundation of a microscope and the place to hold the specimens. Eyepiece or the ocular lens is the lens part at the top of the microscope that the viewer looks through. The diopter adjustment ring allows for correcting the inconsistencies in your vision between your two eyes. Objective lenses collects the light passing through the specimen and focus the light beam to form a magnified image. Zoom knob is usually located on both sides of the microscope head just below the eyepieces. Focus knob. The microscope head can be raised or lowered bringing the image into focus. Light sources. Most of these microscopes use LED illuminators as their light source. Stage plate. Locates under the objective lens, it is where the specimen is placed for viewing. Stage clips helps to hold the slides or other thin objects in place on the stage. The working principle of a stereo microscope depends on two light paths traveling through the objectives and the ocular lenses. Each light path provides a different angle, usually between 10 and 12 degrees, of viewing in each of our eye. Our brain processes these two very similar but with slightly different angles image into a three-dimensional vision. The two eyepieces enables in this microscope a comforting view of the sample from different angles simultaneously. The dissecting microscope has two magnification known as fixed magnification and zoom magnification. Fixed magnification is used in eyepiece to provide a degree of magnification, while zoom magnification offers a different magnifications at different ranges. The total magnification power of the dissecting microscope is a combination of both the lenses present in the microscope, which is the objective lens and the eyepiece. For example, if the objective lens is of 10 times and the eyepiece is of 6 times, then the total magnification power of the dissecting microscope is 60 times.
The first pseudo-stereoscopic microscope was designed and built by a monk called Carabin de Orleans. In 1677, he applied the principle of binocular telescope to the design of a microscope that would permit tiny objects to be viewed with both eyes at the same time. At that time, his goal was not a 3D image. As such, he believed that image quality could be improved by viewing objects with both eyes at the same time. Around the same time, John Leonard Riddle, a chemistry professor and postmaster in New Orleans, presented a binocular microscope with a single objective and a prism system known as Common Main Objective or CMO stereo microscope. In the early 1890s, an American biologist and instrument maker, Horatio S. Greenough, developed a stereo microscope which was an alternative design to the CMO microscope. Much like the design which Father D'Orleans had made, Greenough's microscope used two separate but identical optical paths. He approached the Carl Zeiss Company with his design where the Zeiss engineers changed the plan slightly. Greenough had designed a lens erecting system to ensure correct orientation of the final image, but at Zeiss this was replaced with image correcting prisms. To this day, stereo microscopes are still based on the Greenough principle. Stereo microscopes are commonly used in manufacturing and developing goods, medical technology, and research. Specifically, it is used for dissection of samples, inspection of fractures, microsurgery, cleaned and analyzed fossils, dermatology, forensic engineering, studying living and non-living things, topography, and many more.
Advantages and limitations. Since a stereo microscope is an optical equipment used in low power magnification, it is suitable for larger samples like rocks and flowers. It helps view opaque specimens and allow for microphotography. It also helps in 3D imaging. Yet a stereo microscope is very costly and not applicable for viewing tissue structures, bacteria, and viruses.